Okay, this is section 5.3, and we're going to talk about independence and the multiplication rule. In 5.2, if you recall, we talked about disjoint and the addition rule. So, of course, first we need some definitions. So, we say that two events E and F are independent if the occurrence of event E in a probability experiment does not affect the probability of F occurring. So events E and F are dependent if the occurrence of event E in a probability experiment does affect the probability of event F occurring. So state whether the following events E and F are independent or dependent. So in A, if flipping a fair coin and getting heads is one event, and the other event is rolling a die and getting a 3, are those independent or dependent? Well, the easiest thing to do is ask yourself, when I flip that coin, does it have any bearing on what happens when I roll the die? The answer is no, so these two are independent because flipping the coin does not affect what happens when we roll the die. Okay, what about picking a 30-year-old man who has high cholesterol or picking a 30-year-old man who eats fast food 4 times per week? Well, these are dependent. Why? Well, the probability that you pick someone randomly out of the population that has high cholesterol is one number. But as we all should know by now, if we eat a lot of fast food, we are more likely to have a higher cholesterol number. So if we pick someone who eats a lot of fast food, that changes the probability that the person also has high cholesterol. So those are dependent. So what's the difference between disjoint and independent? Well, first of all, if two events are disjoint, they cannot be independent. Remember, if they're disjoint, the two events do not overlap. And so if we pick something and we know it's in event E, we know for a fact it's not in event F. So that means that knowing something is happened in event E does affect the probability that it is in F also. So I decided just now I don't really like this explanation, so just cross it out. What we really need to know is that disjoint talks about outcomes. And whether or not one trial can have an outcome that is in both events. Remember, disjoint means that it cannot be in both events. So we're talking here about different outcomes, but from one trial. When we're talking about independent or dependent, we're talking about multiple trials, usually. So I do something, and then I do it again, and I need to know whether the first time I did it changes the probability of it happening the second time. So that's the main difference there. Now, this will make a little bit more sense about how this applies when we do a couple examples here in a second. So again, I didn't like this part, so cross out that. So this brings us to the multiplication rule. When two events are independent, we calculate the probability of both events occurring by multiplying. So in mathematical notation, we say that if events E1, E2, all the way up to as many of them as we want to make are independent, then the probability that E1 happens and E2 happens and all the way up to as many of them as we want to make, we just multiply all of their probabilities together. So that's the probability that the first thing happened times the probability that the second thing happened times the probability, that's, etc., until we run out of the events that we've made. So when we see this and we're talking about independent or dependent, and again, remember that usually means multiple trials. The and means multiply. Don't confuse that with the and that's in the product rule, because those are talking about disjoint or not disjoint events. So a roulette wheel has slots numbered 0, 0, 0, and then 1 through 36. A metal ball rolls around the wheel until it falls into one of the slots. So find the following probabilities. What is the probability the ball will land on 17 the first time we spin the wheel, and on 00 on the second spin? So we need the probability of 17 on first spin and 00 on the second spin. So remember, that's going to be the probability that we get a 17 on the first spin times the probability we get 00 on the second spin. So first we have to decide whether or not these probabilities are independent. So what do you guys think? Do you think that when we spin the wheel the first time that it has any bearing on what happens when we spin the wheel the second time? Well, the answer is no. So these two events are independent, which is why we can use the multiplication rule. So the probability of landing on a 17 is 1, because there's one slot that has 17 on it, divided by the total number of slots, which is 38. Because we have the numbers 1 through 36, that's 36 of them. And then we have the two other numbers, 0 and 0, 0. And then we're going to multiply that by the probability of landing on the double 0, which there's still only one slot that has that number out of 38 total slots. So that is 1 over 1,444. Now, you should be learning this in your other class, but if we go to our calculator and we do 1 divided by 38 times 1 divided by 38, we get an answer of 6.925 more stuff, e to the minus 4. So the important thing here is that e to the minus 4. So that was 6.29 e minus 4. And this e to the minus 4 is how the calculator displays scientific notation. And so when we look at the e, if it's a negative number, we move the decimal point left that number of spaces. If it's positive, we would move it right that number of spaces. But remember, probabilities always have to be between 0 and 1. So whenever we calculate a probability, if we get scientific notation, we are going to get a negative number, which means move the decimal point left. So here's how I do that. The decimal point is here now. So I'm just going to go over to the side. So we have 6.29. To move it left, 1 place, 2 place, 3 place, 4 places. So the decimal point is now right here. And for each one of these little spaces I made, if there's nothing in them, we have to fill them in with zeros. So our answer is approximately 0.000629. And if we round that to 3 decimal places, we're rounding to that 0. We look at the 6, which makes it round, the 0 round up. So we get 0.001 for our answer. Okay, we will pick up with the B part in the next video.